Hello students, in the first lecture I have discussed about the introduction of machine drawing, its application point and what is the basic things need to be followed while drawing hatching, while drawing the representations, while maintaining the angles, all these things, how do we do sectioning and all. Today I'll try to draw the conventional representation of different materials and what are all the angles need to be followed and how we draw those angles and the parallel lines with the help of a drafter. Okay, conventional, I'll make it so simple, conventional representation of materials. Remember, we are dealing with only materials, not the machine components. Okay, conventionally you can draw, as I said in the last lecture, you can draw a rectangular piece or a box, you can draw a circle, elliptical cross section, but the whatever the profile you will draw, that has to be closed to show your hatching. Okay, I'll repeat some points related to last class or last lecture. Like we discussed about sectioning, we discussed about hatching. Try to remember these 2 points. Why we do sectioning, what sectioning actually means. Sectioning nothing but cutting the part into 2. Sectioning could be full sectioning, could be half sectioning also. And hatching, after sectioning you need to represent or show the cutted portion with the help of parallel lines. It is not parallel all the time, it all depends on the material. You need to remember these 2 points throughout your machine drawing subject. Fine. Now convention, what is the meaning of convention? Here we are going to draw our own dimensions, show our own dimensions. Those rectangles or square boxes or circles or elliptical cross sections are not maintaining any dimensions. We are taking our own dimension based on the space availability to represent so and so X component or a material on your drawing sheet. Fine. Now here, whenever somebody asks you or some question you get in your internal examination or else in your external examination, you need to draw a box, tabular box of this kind. Okay, saying that type, number 1 is type, number 2 is convention of so and so material, number 3 is material. Fine. It is not compulsory to draw a table all the time. You may not get much time in your internal or external examination because you need to deal with many other components or many other sketches. So it is not compulsory. Fine. If you get much time, you can draw it in the form of a table. Fine. When you draw a metal, write it as metal. Again, it is not compulsory to write capital letters only. You can write small letters also. Fine. Then followed by a rectangular box. Now this rectangular box is not having any proper length, proper width. Okay, this all depends on the sheet or space availability of your drawing sheet. Okay, I'll try to enlarge the component. I'm trying to draw a box of 100 by 50. Fine. I'm trying to draw a box of 100 by 50. Okay, we'll try to show it this way, 100 by 50. Okay, it is not multiplication. In engineering practice we call it as 100 by 50. Fine. Length and breadth you can call it as. It doesn't have any thickness. Okay, now I need to hatch the component as we discussed in the last lecture. Here I need to make a mark. For example, we need to draw parallel lines throughout the box. Then what I try to do, I'll try to maintain the 2 thickness, 2, 4, 6, 8, 10, 12, 14, 16. Okay, similarly in vertical line also 2, 4, 6, 8, 10. Fine. Align your drafter. As I said, I'll again draw the same sketch. This is your drafter, for example, which is having all the units on a centimeter scale followed by angle 0 to 9. Now if you take this as the 0th line, this is 90 degrees. Fine. Now if you want to maintain 45 degrees, what you need to do? Positive 45 degrees. Okay, rotate your scale to positive 45 degrees this way. Now for example, this is your scale. If you rotate to 45 degrees, just focus on horizontal scale, not on a vertical scale. If you rotate to 45 degrees, where you could see a knob on your drafter which will maintain that 45 degrees. Okay, align your horizontal scale to that particular knob, then tighten the screw which is given on the drafter. Tighten this particular screw. Take that scale, for example, your scale will be something like this. Okay, this is after rotation. This is the position of your drafter after rotation to 45 degrees positive. Fine. Now take your drafter place it on the first point and try to draw a parallel line, which is very simple. Try to draw a parallel line, which will help you in drawing uniform lines. Okay, now which will maintain an angle of 45 degrees with an offset distance of how much? 2 mm. As we discussed in the last class, it is not compulsory to maintain 2 mm all the time. It all depends on the size of your component. If the size of the component is bigger, then you can go with 3 mm also, not a problem. Fine. So I'll repeat the same sketch. I need to draw this way. Okay. Now in conventional representation, no need to show dimensions. Okay. As I said, it is not compulsory to draw rectangle. You can draw a circle also, followed by hatching. Why we do hatching? Because it is a section component. That is the reason we do hatch. Fine. So this hatching for metals of what type? Metals like steel. Again, you need to write the representation also. What for this pattern is applicable for steel, cast iron, copper, copper and alloys of it, then again aluminium, then again its alloys, etc. Fine. Now this pattern is applicable to these all materials, this type of material, steel, cast iron, copper, whatever the material you deal with, among these you need to apply this particular pattern, which is very much important. Clear? Now again, in metals again we have some other types like lead, tin, zinc, okay, and white metals. For this type of materials, again we need to draw a box of 100 by 50. It all your convenience. You can draw 50 by 20 also, not a problem. For example, some 50 by 20. No need to show the dimensions. For your understanding purpose, I am showing it. No need to show the dimensions. For your understanding, I am trying to show the dimensions. Fine. Just draw a box or draw a circle or draw an ellipse, followed by these dots, what I said. If you want to maintain offset of 2 mm, 1, 2, 3, 4, maintain those dots, followed by parallel lines similar to cast iron, steel, copper alloys, okay, followed by these lines. Okay, if it is lead, tin, zinc or any other white metal, 45 degrees positive, then 45 degrees negative. Okay, this is a pattern applicable for lead, zinc, tin, white metal, etc. Okay, now if you could manage with a table, you can draw it, but table will take more space out of your drawing sheet. In examination, it is not possible to draw all the time a table followed by a box, then all the names of the materials. It is not possible because it will take more time, more space also. You can make it simple. Like for example, if this is question number 1, make it question number 1 followed by a box and its names. Like this is applied to so and so, steel, cast iron, copper, alloys. Fine. Now this is about metals. If you take a glass, if it is a glass, if the sectioned component is a glass, what you do? If the section 1 is a glass, then again similarly draw a box of your convenient size. That could be 30 by 20, 50 by 60 or 100 by 50, whatever the convenient space available, followed by 45 degrees inclination again. For all the three we are maintaining 45 degrees. Okay. For lead, zinc and tin, maybe we are going with minus 45 and plus 45. In case of glass, what we try to do is, again we go with 45 degrees inclination, followed by, have a look, one parallel line 45 degrees inclination, followed by two lines on either side of that particular parallel line. Okay, one parallel line and two lines maintaining 45 degrees again on both sides of that particular parallel line which you have drawn before. Okay, I'll repeat. Draw a box of any convenient size followed by a 45 degrees line. Okay, two more lines parallel to it on both sides. If you want, you can increase the number of lines. Okay, two more lines which will maintain both will maintain same distance or length, followed by two more lines. Now this is the representation of what? Glass. If the cutted portion or a cutted component is a glass, you need to represent in this way. Okay, forget about the length of the lines. Okay, conventionally try to represent it. That is enough. Okay, if the material cutted or section is a packing and insulating material, maybe packing and insulating material, what you do? If that is the case, maybe the packing is made of stoneware or marble. Okay, packing, asbestos fibers, felt, synthetic resin products, papers, corks, many other leather packing will also be there, rubber type of packing will also be there. In such cases, again same, we will draw a box of convenient size, then followed by, for insulating material, same 45 degrees inclination, but this time don't draw this continuous lines. We try to draw discontinuous lines, something like this. Now all the discontinuous lines are maintaining an angle of 45 degrees with an offset of 2 mm, but the lines are not continuous, discontinuous. That is only the difference between this packing, insulating and the cast iron. Okay, cast iron or steel we use continuous lines. In this case we use discontinuous lines. That is the only difference that you need to remember. Okay, now if it is a synthetic resin products or a rubber or a leather or a wax product, then again same box of your convenient size, then followed by horizontal lines which will maintain an offset of 2 simple horizontal line, which is very much simple again. Okay, followed by 45 degrees inclination with an offset of 2 in between two lines. Okay, we'll draw a box similar to cast iron, similar to glass. We'll draw a box of convenient size, then parallel lines which will maintain an offset of 2 an angle of 45 degrees. Again these 45 degrees lines also maintaining an offset of 2. Okay, so what are the similarities among all? You need to know the similarities among all the patterns. Similarities are, most of the patterns we use 45 degrees inclination followed by 2 offset distance. This is the similarity between all the patterns. So it becomes so easy for us once you practice. One time practice is enough. No need to practice continuously. Before exams, if you could manage to visualize once, that is enough. Not like other subjects like fluid mechanics and some other problematic subjects. Once you draw a sketch, if that sit in your memory, that is enough. Okay, for liquids also there is a representation same to the way we have drawn glass and cast iron. Draw a box followed by discontinuous horizontal line, this time discontinuous horizontal lines. Okay, for packing and insulating material we have taken discontinuous lines, but those are maintaining inclination of 45 degrees, whereas in this case this is maintaining horizontal 0 degrees lines with discontinuous. Okay, in case of wood, for example, if the cutted material is wood, same box of your convenient size followed by dissimilar pattern. For example, if you cut a tree, the cutted portion will look uneven completely. There won't be any proper uniform pattern. In such cases what we try to do, we'll try to draw this way in a zigzag way with our free hand. Okay, like a spider. Okay, in a zigzag way, zigzag patterns we'll try to draw. Fine, have a look, we are drawing some zigzag patterns. This is the indication. There won't be any uniformity because it is made of wood. Fine. Now in the same way, wood, for plywood also, the components which come under a category of wood, maybe it is a plywood or some other teak wood, the pattern would be same. Fine. Lastly, concrete. Okay, now same box followed by dots, so many random dots, there won't be any uniformity, followed by filled triangular boxes. What does it indicate? It is a concrete. It indicates that there are stone petals, then followed by sand. Concrete followed by sand. Okay, this is the representation. So this is about conventional representation of materials. Okay, if the question, you may get a question like, draw the conventional representation of cast iron, glass, wood, then some concrete. Okay, which will carry some 5 marks. Which is very much important, very much easier. Okay, no need to work hard much, because only thing is you need to manage with a rectangular box, 5 rectangular boxes, or whatever the question, 4 or 5 rectangular boxes. Fine. Cast iron, which will maintain an angle of 45 degrees with an offset of 2 mm. Glass, which will again maintain an angle of 45 degrees followed by 2 more lines or 3 more lines on other 2 sides of that particular line drawn before. Wood, similarly some uneven pattern, something like this. Similarly, concrete, what you do, lastly what we have studied or what I have explained, dots, random dots followed by triangular pieces. This is the indication. Okay, this is for cast iron, this is for glass, this is for wood, this is for concrete. Fine. So if you have any doubts in my presentation or lecture, you can mail me You can ask your questions anytime. We are here to help you out. Thank you.